Hey guys, this is the lecture for Chapter 3, Properties of Water, and this is for Idea Alamo College Prep. You're more than welcome to follow along with us if you would like. Here's a hydrogen bond between a partial negative and partial positive charge between two waters. So let's go ahead and get started with the lecture. What four emergent properties of water make life possible? Cohesion and adhesion, which allow for capillary action, high specific heat capacity. It expands when it freezes. It's considered the universal solvent. And so these are the four properties that make life possible. All of these properties arise because water is polar. Water forms hydrogen bonds. Let's look into this a little bit more when it comes to capillary action. So our question is, what are cohesion and adhesion, and what exactly causes them? Cohesion is the attraction between water molecules caused by hydrogen bonds. This is going to create surface tension, which allows some animals to walk on water. Just like the quiz that we had, we have striders that have hydrophobic ends on the bottom of their legs that help them walk. Adhesion is the attraction between water and a surface. This is caused by hydrogen bonds. So these hydrogen bonds are bonding with the surface, and it's going to cause them to have this minuscule effect. So what is capillary action in the first place? Capillary action is cohesion and adhesion working together, which causes capillary action, and it occurs when water travels up a narrow pathway, this should say pathway, against the force of gravity. The more narrow the tube, the farther the water will travel. Capillary action helps water travel up the stems of plants and through the capillaries of animals. So what is heat capacity? What is specific heat capacity? Heat capacity, the energy, which is the energy required to raise the temperature of an object or body of air or liquid by 1 degree Celsius. Specific heat capacity is the energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So these are specific heats for different things. So which substance needs to absorb the least amount of heat energy in order for its temperature to increase by 1 degree? So if we look at this, the smallest number is going to be 100. Which substance needs to absorb the most heat energy in order for its temperature to increase by 1 degree? If we look at the table again, the biggest number is 4,200, which is water. It requires the most energy. Now this question, what takes longer to heat up, metal or water, and why? This one is actually on your notes. So, do you think it'll be metal? If we look at metal, metal is around 450 for iron. So which one do you think will take longer to heat? Iron with a 450 specific heat capacity, or water? If you said water, you are correct, because it has a higher specific heat capacity. So what causes water's high heat capacity? Water's high heat capacity is due to hydrogen bonding, because there are so many hydrogen bonds attracting the small water molecules to each other. A lot of heat energy is absorbed as hydrogen bonds break when water heats up. A lot of heat energy is released as hydrogen bonds form, like when water cools down. So let's take a look at this little map of California. Which cities experience the least extreme temperature increases during summer? If we're looking, we would see that it's places along the coast. Which cities experience the most extreme temperature increases during the summer? If we're looking, we're about 40 to 80 miles away from the coast. Look at these huge numbers. Yikes, that's hot. So the question is, well, why? So how does water's high heat capacity help it stabilize temperature? Water has a high heat capacity. This means it can absorb or release a lot of heat energy without a large change in its temperature. Lakes and oceans stabilize environmental temperatures because the water in them can absorb heat from the air and release stored heat to cold air. Water also stabilizes body temperature since we're mostly made of water. Sweating cools us efficiently due to water's high heat capacity. The water in sweat absorbs a lot of body heat before it evaporates. So why does water expand when it freezes? As water freezes, the hydrogen bonds form crystal structures that push the molecules apart. This causes water to expand as it freezes. As a result, ice is less dense than water and it floats. So we're looking at ice on top of this lake with a fish. What would happen to lakes and oceans if ice was more dense than water? If you said it wouldn't float, you are correct. The ice would probably crush all the things that are living in the water. So why is ice's lower density important for life? If ice sank, bodies of water would eventually freeze solid. The layer of ice on top of a frozen lake or ocean insulates the water below. This keeps the water warm and allows aquatic organisms to survive. So why is it considered a universal solvent? Well, water dissolves many substances because it is polar, and it forms hydrogen bonds easily. When ionic compounds dissolve in water, each ion is surrounded by a sphere of water molecules called a hydration shell. When polar molecules, partial positive and negative charges, dissolve in water, water molecules are attracted to the polar areas. Nonpolar substances, like oil, cannot dissolve in water. Now on your notes, in the back of them, you have an area that shouldn't be there. So go ahead and ignore the one that says, how does molecular shape allow for specific binding? We're just going to review hydrophobic and hydrophilic real quick. So let's just review this. This was in our last series of notes. But since we're talking about water, we should talk about hydrophilic and hydrophobic since we'll be talking about cell membranes. A hydrophilic dissolves easily in water because it has polar areas like salt and glucose. A hydrophobic substance does not dissolve in water because it is nonpolar, like oil, fat, and lipids. So which part of a phospholipid is polar? Look for the partially positive and negative area. If it has a partial positive or negative charge, it is considered polar. Is it the green area or the blue area? Where do you see a positive and negative charge? If you said the green area is polar, you are correct. If you said the blue area is nonpolar, you are correct. We have a positive and a negative charge here, and we have a bunch of hydrocarbons here, which means it'll be hydrophobic. Well, that's it for today. Please make sure that you fill out your summary to ensure that your notes are done. I'm very excited about tomorrow. We're going to have a lot of interesting demonstrations, and we have a little experiment in the beginning. Thank you.